Hello, everyone. This is Aran. I'm an educator of philosophy based in Austin, Texas. Today, I will have a conversation with my great friend, Tren. Hello, Tren.
Hi everybody, this is Chen, a friend, cultural historian from Europe and China. Great to be here today.
We are continuing our conversation on John Odling Smee's book, Niche Construction, how life contributes to in its own evolution. And we have started talking about the basic layer that Odling Smee thinks uh, actually impacts our understanding of evolution, and which is basically returning to the very basic concept of biology, which is life. And ultimately, what Odling Smee is going to tell us is that if we really understand what life is, we cannot maintain the standard evolutionary theory, not because the modern synthesis is wrong, but because it has a partial, incomplete view of what it takes for life to exist, persist, and get passed on to the next generations. In other words, evolution. The conversation that we had last time revolved around the concept of information and its relationship with life, and how life and information are both entangled with energy and the flow of energy. One of the main focuses of our conversation, the last episode, was on the concept of information more specifically, and we delved into Shannon's information theory. Before getting into a summary of that, Trent, do you have anything to say at this point?
No, let's just carry on.
Of course. So, Claude Shannon, has a theory of information that is important for Odling Smee. Um, Perhaps because what Shannon does is that he introduces a concept of information that is independent from intentionality, purpose, or even having a neural system in a biological sense, or a brain. And that is important because if we're thinking about life and we're thinking about information as it is intertwined with life, we cannot just start life at like multicellular organisms, right? And we need to think about far more basic structures. And Odling Smee thinks that even at those basic levels, it is meaningful to talk about information. It is meaningful to talk about information, energy, and its relationship with life. So Shannon's information theory, because of its subtlety and non-intentionalist type of approach, is something very charming to Odling Smee's project. Now, what is Shannon's information theory? Just a brief summary of what we're dealing with. Information for Shannon is about a degree of uncertainty. The less uncertainty, the less information, and vice versa. And when we want to know what is really um, what information or exists within a system, or in another word, what information do we need to solve a problem within a system, we basically want to see how we can reduce uncertainty, or how fast we can reduce uncertainty. And the filtering for that is that how many binary questions of yes or no questions minimally we need to get to the outcome of a system. And that is measured in bits. The way this got interesting and relevant for our purposes was basically the Theseus maze experiment that basically shows us how a robotic mouse called Theseus could ultimately adapt to a maze, learn its way and gain information through interacting with that environment, to get the adaptation needed to figure the maze out, basically, without introduction of any semantic information, without introduction of any sort of internal purpose, intention, even like any sort of sophisticated internal organism or anything like that. And this is something that is going to be the basis for Odling Smee. Not that he endorses Shannon's information as the uh, be all kind of a theory of information in the biological sense, but it can be the bedrock of what he wants to build. Basically, Odling Smee build his understanding of information in the biologically relevant sense on Shannon's information theory. Right?
No, you have done a great job at recapping what we discussed so far, and we can take it from here and see what kind of nuances perhaps the audience me is trying to add onto this information theory.
One thing that we kind of need to remember about Shannon's thesis to get to the point of seeing how gets related to the evolutionary story that Alding Smee is interested in is to unpack this claim. Shannon's thesis learns historically. Okay. And there are a number of things that are happening that is important to kind of track. And all of them are going to use terms that we are more familiar with in a more kind of a human context. And we need to kind of abstract from those and get to the basics of it. Okay. But as you're going to see, the skeleton of this kind of the structure is going to remain the same for different information inheritance systems that Alding Smee wants to talk about. Number one is that the move from information to knowledge. Remember, information is about uncertainty. The more information we have, basically means the more we have reduced uncertainty within a system. And when we turn that into sufficiently close number to zero, meaning that there is no uncertainty, or very, very little uncertainty, we can use the term we have learned something, or we have knowledge necessary in that system. Knowledge in this sense does not need to be intentional, conscious, human, or like any even like living. It just means that an entity could begin from the position of being in a system with a lot of uncertainty, get to a point that that uncertainty is reduced, and reduction of the uncertainty manifests itself into proving that that entity can solve a problem within that system, which is exactly what Theseus does, right? Theseus doesn't know, quote unquote, how to go about the maze. Theseus learns by reducing uncertainty at each juncture. And after the whole thing is done, all the relays in the maze are in the correct positions, meaning that the Theseus in our story will find its way out of the maze effortlessly, with no uncertainty, with no reversal, with no expenditure of extra energy to understand, to get to know the system, right? Remember that, like in the original trial and error phase, like the Theseus would hit the wall, would spend energy, go to the wall, spend energy to come back, right? All of that is spending energy. That is part of that information gaining process. And the next round that it goes, none of that is required. It can just go. Now it has learned. So we have this information in the form of uncertainty, reduction of it equals learning, learning equals and know-how. Okay. Now the important thing is a form of like one of the important things here is that somehow the each step needs to be connected to the other steps, right? And the information of each step needs to be added to the information on the next step, right? So this means that like we have Theseus on the first juncture at the very beginning, and then we have Theseus at the last juncture after some of these, most of these trial and error episodes have been done. Um, there has to be a way that the whatever information, whatever binary question was asked, whatever uncertainty was reduced on the first phase, um, needs to be somehow contained in the future self of Theseus. Um, to make the knowledge sustainable. Now, we talked at the end of the last episode about something peculiar and fascinating about the original experiment, which is that, like, in fact, in the original experiment that Shannon put forward, it is the maze that remembers. It is the maze that kind of like transmits all of this information so that the whole maze is now in the place of inheriting the information. But in reality, like it doesn't matter what is being transferred to where. Like it matters for other reasons, but for this purpose doesn't matter. It matters that like the information is inherited, right? And of course, this inheritance could take shapes of, you know, if we have like another mouse, right? Like the information, if we want the mouse, the second mouse, to not go through a trial and error period, we have to somehow transmit that information to the new mouse, right? That's going to be necessary. All of this is pointing at something that is ultimately very important in all information systems: memory. Theseus could only learn if it remembers, right? And the cold beauty of all this is that Theseus remembers without having any apparatus to remember. Again, in the original test of Shannon's maze, it is actually the maze that remembers. But we can easily switch that up by thinking that, you know, we have a robotic mouse with some form of a memory, very kind of like computer version of memory that remembers that which relay worked, which relay didn't work. That is not the important thing. The important thing is that each lesson of every juncture need to be remembered and accumulated so that ultimately the mouse can get out of the maze. Or more importantly, if put in the same maze again, it could find its way. Right? Otherwise, one thing that could happen is that it could go through one round and then it forgets, it resets, and then it hasn't really doesn't know to go about the maze. Or the every like a step gets gets forgotten, and that creates a similar type of a problem. In the maze example, that is not as clear, but like think about it in the case in like with the case that I brought up last time about the die that has four numbers on it, right? I told you that this is a two-bit information system because it takes two questions to get to the answer, to the answer of like what has been rolled. Well, why two bits? Because I need two binary questions to get to the answer. Is it one or two? Yes, no. Is it, one or two again, or three or four? Yes or no. That's what is needed. But the trick is that if I ask is it one or two, and the answer is yes, and I have Alzheimer's disease, and I don't remember that, I don't get to the second question, or the second question doesn't really have the same function anymore, right? Um, so there is, I think this is important and interesting because it makes sense of the necessity of a form of consistency of registering something and being able to retrieve it as what it is. This requires some form of identity through time, right? Imagine like a third person has rolled the die, and I ask the question, is it one or two? And I get a response, but I fade away, and Tren comes in, and I don't share that information with Tren. That just means that there has been a rupture of continuity that is necessary for an active memory, right? Now, this is going to be super interesting and exciting, not just because of like how this is going to be applied for like, genetic transmission or how antibodies work, but also like later on in our conversations, I think it's going to be very interesting in terms of like cultural memory, and how like that how from the existence of cultural memory we can assume a continuity of identity. And I think that is something super interesting in the arguments about justification of a state, or meaning of a state, or meaning of a nation, or like those types of concepts, or civilizations and things of that nature. Um, But all of these things that might be applicable to cultural memory are just being derived from Shannon's thesis. As simple as that. Trent.
Yes, so two more points to emphasize a bit. One is knowledge, as you put it here in both point two and point three. It's use it could be utilized by both the future self and future other agent or being. And therefore, like knowledge or information is something to a certain extent autonomous, a unit that could transfer its owner, yet still maintain a sense of internal structure, which is really interesting when we use this to analyze the evolution of life, because life itself also tries to do the same. Yet the two do not necessarily match each other at every stage. Knowledge could be produced and utilized only within one member of a population's life history, or it could be shared across. And so we're interacting with a different time scale and timeline here. Second, I really like what you emphasize about identity consistency, which I think another way to put it is like this slide is talking about how informational knowledge that it should be placed in time because it is intrinsically historical process in terms of making and transmission storage. And the big picture, what we're really interested in is like agency in history. That is precisely what you're saying. We need a sense of identity, need continuity, consistency to be able to recognize and exercise agency in history. And that's the place where um, topics not concerned in evolutionary theories, for instance, like state formation, religious evolution, could benefit from this kind of historical perspective of information transmission. Yes.
Yes. And all of these like other application part of it actually is gonna come off at the end of our discussion on Smee, but I'm sure it's gonna have more presence later on. Um, Excellent. So there are I think like two things that we need to add to really kind of get on our path to see like what Odling Smee wants to really do with all of this. And to do that, to kind of like make the move from this kind of Shannonian information to the adaptive know-how of like biological systems, is to remember that Theseus was just there. Theseus did not have anything to do to find the way out of the maze. It just was like a very mechanical, step-by-step thing to just kind of get in there. Uh, Shannon had his purpose, but Theseus didn't. And oddly, the Smee thinks that living beings are different. Living beings have purpose, and that purpose is to survive and reproduce. Now, we're going to get back to this in the kind of critical remarks section of our conversation, but there is like an ambiguity there because purpose in what sense? Like in what sense bacteria have like purpose? And I think perhaps like the more important thing is not so much about purpose, but like kind of the where the like mover is. And I think it's the mover of a living being is an internal structure, and that's not the case about Theseus. And all of this internal, external mover or motivation or kind of like start of a chain of reaction is something that is going to be very interesting and excited to explore more. But in any case, Odling Smith thinks that that's one of the differences between Theseus and like a rabbit. Um, the second thing is that we said why Shannon's information theory ignored meaning, but that is going to be tricky in um, in evolution because the information, like, and I think in the case of like Theseus is just like um, it doesn't really like it gets closer to the living organisms. There are some layers of the Shannon's information theory that are just like about like how many bits to solve a puzzle independent from the meaning of the puzzle, right? It becomes something like that, and like that layer of this cannot exist or cannot be the whole story about evolution because you need to transmit information, you need the transmitter, you need very similar processes that we see like in Theseus, but you have a very specific demand, and you need to also be flexible about that. Your relation between your information and your demands, right? Because like let's just let's talk about it through an example. Like you might receive something genetically from your parents that really kind of tells you to do a certain thing in a certain situation, right? And that was a very kind of adaptive, great thing to do in that environment. Let's say consume sugar, right? You will have some sort of a genetic structure, and that genetic structure will tell you to consume sugar because sugar gives you energy, and sugar was rare because you couldn't get enough sugar. So if you find sugar, just get it there. You gotta use it. You gotta have it. Okay. Now things have changed. Sugar is far more accessible. You have the same genetic structure and you have the same desire. Now you better reinterpret that knowledge that is given to you as like a genetic information because the environment has changed. Um, and the selective pressure has changed. Perhaps now overconsumption of sugar is a far more dangerous thing than losing access to sugar as your survival is at the stake in that question. So whatever information has been transmitted, the meaning of that needs to be readjusted based on the nuances of the current environment. Otherwise, the information is not adaptive anymore. Just kind of like a very kind of formulaic way, we can say that like for living beings, insofar as evolution is concerned, the information needs to remain adaptive. And if it doesn't, that's a problem. Whether you can combat that, whether you cannot combat that, what does it mean to combat that? Is combating something like sugar, obsession with sugar requires another kind of genetic change in the population, or it is like a different type of like reinterpreting that demand, reinterpreting that piece of information about necessity of sugar or not, that's a different problem. The point is that this whole information story in the biological evolutionary sense cannot be framed without reference to meaning. Trent?
Yes, I really like the sugar example you just gave. It seems probably this is not a place to really elaborate. We should reserve it for later, but I just want to signpost a little bit that it seems that there are two types of information or knowledge involved in this process of comparison. One is that kind of more direct, like how to get sugar, and the other is like a kind of it that is not connected necessarily with the, or at least not self-consciously connected with the overarching purposes of life, living beings, as Alan Smith put here, to survive and or to reproduce. Of course, in normal situation for vast human history, like sugar is rare, and to get it as much as possible is conducive to reproduction. However, in like say in our time, when the environment changes, to introduce a new piece of knowledge or information, this is produced through active self-examination and see whether certain piece of information still fits one's current overarching objective or purpose, namely to survive, to reproduce. It seems that there's different level of knowledge introduced in the way people like control themselves, not let their impulses to take them to sugar consumption. Yes, that's just a reflection of what you said. Do you have anything to respond to that?
No, I think that's a very good point. I think in terms of this kind of like there's always this kind of other layer. Or let's put it like in a more kind of less like intentional way. The organisms that could always keep track of that ultimate purpose of all of these impulses have a better chance of survival
Mm.
or have a better chance of adapting to the new things that are thrown at them in an environment. And the ones who lose that and only have the impulses as as eternally accurate information transmitted by the past generations to them, they have a less chance to survive. And I think like in that sense, like we're getting to that whole point of how much how much competitive advantage agency in general has in the evolutionary sense, which will be very much intertwined with the point about niche construction that we're inching our way towards its
Oh.
articulation. Now, as Trent started to kind of mention the when we think about information for Odling Smee, and when we kind of understand, like putting alongside a couple of things. What is life? The bioinformatics, bioenergetics, and inheritance. Um, the whole thermodynamics of life, and the whole idea that information is needed for manipulating energy, and energy is needed for acquiring information. The second line is information in terms of like reducing uncertainty and making things predictable, and understanding that that will happen only if some energy is spent. And that's in some basic way, a quantifiable way to do it. At least Shannon suggests that such quantification exists. Now, we have some understanding of basic elements in information. We have some basic understanding of what it takes to not only be alive, but continue to be alive and continue life. Okay. Now, this takes Odling and Smee to get these points connected and ask himself what kinds of information systems and inheriting information are relevant for evolution of life. And the inheritance system that standard evolutionary theory is very much like recognizes is a population genetics, right? Because we could easily think about population genetics as an inheritance system that is about information. That is probably the most Theseus-like part of this whole narrative, because we don't need to invoke like intentionality for proteins, right, or DNAs. What is going to become important is that, or the main probably argument of this whole book is that inheritance, genetic inheritance system as a form of information transmission is necessary but not sufficient in explaining how and why species survive, or in a more basic way, how and why life exists and continues to exist. We need two other layers to understand that. We need two other ways of understanding inheritance systems of information to understand how evolution really happens. Of course, there is a layer of evolution is just happening at the genetics level, and a lot of these points about information will be applicable in that, if not all of them. The point is an addition, not a reduction. It is not to eliminate, it is to add to the list. And these two systems that ultimately end up being information inheritance systems or information energy manipulation systems are individual learning and cultural transmission. And the question that we're going to have is that how does niche construction make the relevance of individual learning and cultural transmission to evolution? How could we make sense, in other words, that individual learning and cultural transmission as systems of information inheritance are relevant to evolution of life is answered by understanding what it means to say organisms are niche constructing entities. Trent?
Yes, I want to just end this discussion with first a quick response to the recapitulation what you just said, and the second is something not necessarily a digression, but I think it's kind of flourished by observing certain parallels between what Alan Smee does here and certain historians, cultural historians, does for textual analysis, which is kind of my stuff. So the first thing is I really like the big picture um, thing that Odling Smee puts. As you mentioned a couple of episodes ago, that he provided this niche construction theory not to displace or dismiss the relevance of genetic studies or standard evolutionary theory, but to enhance it or supplement it. As you put the three levels, they're very clear. One is precisely addressed by those theorists that are centralizing or foreground the importance of genetic studies. However, by introducing Shannon's information theory, Odling Smee effectively I won't say dethroned, but at least parochialized the genes. Genes is not the only thing that matters in the transmission of knowledge. There are other things that mattered. If we zoom out and not just um, place the boundary between genetic and non-genetic stuff, or genetic life versus non-genetic and abiotic, instead of considering information, we'll see actually there are multiple layers or multiple lines of transmission happening at the same time, and genes just but one of them. And we there's no way for us just to consider it if we were to understand the sustenance of life as balancing the need between energy and information in general. We need to understand all structures of energy flow as well as structures of information production and transmission. So that's the response. It's like his model is like parochializing genes in a much wider landscape of the information production and transmission. So second thing I want to mention is a very interesting parallel between the way the Odling reacts to those genes alone type of theorist. So in cultural history, we have some scholars who say we are doing literature at the end of the day, philology, text, because or symbolic interpretation of the past are available to us through textual production or symbolization. And the strand of the reaction towards that is no, you need to consider what the what texts really are in nature. They are but a formalized communication pattern and expression. If we're considering so, we cannot just look at text. We should look at other types of like formalized communication, perhaps the rituals like a movement, systematic guided movement of population, things of that kind. So I just wanted to express how interesting this at like this kind of meta discursive level, we can draw parallels between debates happening in different fields. Yes.
I think that's an excellent point, and I think it is interesting because I think it is both interesting to see the parallel, and also I think we can use that to better like kind of elucidate what really Odling and Smee is doing. And I think like there is like there and you mentioned this, I just want to kind of maybe repeat it in a different way, that like the kind of the textual like heritage type of um, approach to research could say that, oh, ultimately it doesn't matter what else happened. It just matters that like here are the things that survived, here are the things that we have. And I think someone could criticize that like you do not know what exactly has survived and why unless you look at the things that are like in between these survivals of these texts, um,
Mhm.
not just the texts themselves. And I think in a lot of ways, that's how the Odling Smee kind of engagement with standard evolutionary theory is going. It's not that genes didn't survive, but like you're not understanding what it means for genes to survive. And because of that, you have an incomplete story of what it means for life to evolve or how that process really happens. You just kind of hyper focus on one layer of it. But I think this is a good place to stop this episode. What we're gonna address is gonna be the exact question that you're seeing here. We want to see how niche construction, which finally is emerging as a major concept in our conversations, uh, is going to make it clear why individual learning and cultural transmission play significantly important evolutionary roles.
Yes, dear listeners, thanks for your attention. Please stay tuned. Our further discussion about the Ellen Smith's the theory of niche construction is coming up.